Hello again. Today we're going to look at the properties of addition and multiplication when it comes to expressions. So let's get right to it. So when we were looking at expressions, remember an expression is just a mathematical phrase with numbers and operations, and if it's algebraic, it will also have variables. So we're going to look at the different ways that we can look at expressions to make them equivalent to each other. And equivalent just means that those expressions have the same value. So expressions with the same value are called equivalent expressions. So for example, 12 plus 7 is equivalent to 7 plus 12 because their values are the same when you go ahead and do the math, when you add in this case. So we're going to look at some properties that allow us to make equivalent expressions. Some of our expressions will just be numerical and some of them will be algebraic. Which means they'll just have a variable. So we'll be looking at those different types of expressions, and we'll be looking at the properties as they relate to adding and multiplying. So when I say the commutative property, you can have the commutative property of addition and multiplication for, depending on which operation you're using. And we're going to look at the associative property also of addition and the associative property of multiplication. And then we're going to look at the zero property of addition and the multiplication properties of 1 and 0. So we're going to look at all of those things that make equivalent expressions today. So these are probably review for you, but it's really good to review and go back and try to remember these things. So the commutative property means that changing the order of the parts of your expression does not change the outcome. So that's a commutative property. Changing the order of the terms in your expression does not change the sum or the product. And if you remember, sum and product are the answers to addition and multiplication problems. Oops, sorry about that. All right, so you get a little bit better view there. Okay, so we're going to write down some examples with just the numbers and then some that are algebraic. Okay, so for example, the commutative property of addition. 5 plus 8 is the same or is equivalent to 8 plus 5. Okay, so that's the commutative property of addition because I'm adding in that case. Same thing with multiplication. 5 times 8 is equal to 8 times 5. So when I flip-flop those terms in the expression, the value doesn't change. The same thing will happen when I have variables. Okay, and I could have one or two variables. A plus B is the same as B plus A. So that's the commutative property of addition. Look a little funny there. Commutative property of addition with variables. Okay. Same thing. A times B is the same as B times A. All right. So this is our commutative properties of addition and multiplication with numbers, addition and multiplication with variables, okay, our algebraic expressions. So just remember, commutative means I can change the order of the terms. All right, let's go down a little bit. The next property is the associative property. And the associative property says that changing the grouping of the addends or of the factors does not change the sum or the product. And addends are just the parts of an addition problem. Or factors, which are the parts of a multiplication problem. Changing the grouping of addends or factors does not change the sum or the product of our expressions. We'll look at some examples of that. Push this up here. So again, we'll look at some numerical examples, and then we'll look at some algebraic examples. So if I have 7 plus 4 in parentheses plus 2, that's the same as if I group together the 4 plus 2 instead. So with order of operations, when we have the parentheses, we do the parentheses first, and then we drop the parentheses and do what's outside. So on the left, I would add 7 plus 4 together first to get 11, and then add 2 to get 13. On the right, I would add 4 plus 2 together first to get 6, and then add 7, and I would still get 13. So because the sum doesn't change, I have two equivalent expressions here. Okay. Same thing with multiplication. I can group together 7 times 4 and then multiply by 2 on the outside, or I can multiply 7 times the grouping of 4 and 2. I'm still going to get the same product in that case. So 7 times 4 is 28, times 2 is 56, or I can multiply 4 times 2 and get 8, and then multiply by 7 and get 56. So again, I have equivalent expressions to get the same product. So that's looking at the examples of the associative property of addition and the associative property of multiplication with just numbers. But the same thing, again, works with the variables. Okay, so whether I add A and B together first and then C, or I add B and C together first and then add A, it's still going to get the same value, or same sum with the property, associative property of addition. And with multiplication, A times B and then times C is the same as multiplying B times C first and then multiplying by A. Again, all of your expressions are equivalent to each other, even though they're grouped differently. Okay. So what we can do is we can use these properties here to help us simplify expressions. Okay. When I'm simplifying my expression, what I'm doing is I'm combining the terms that are similar or alike. So I'm combining constants together, or I'm combining variables that are the same. Okay. So I can use these properties to help me simplify long expressions into smaller expressions. We talked a little bit about this last week. So when I simplify, I'm just combining like terms. And when I mean like terms, I mean terms that are constants or terms that have the same variable. So let's apply these properties to be able to simplify our expressions. If I have 7 plus the quantity 12 plus x, okay, I can't add 12 and the variable x together because I don't know what the value of x is. But I have two constants here. Now, even though they're not in the same group, I can switch the groupings because of the associative property and make equivalent expressions. So I can switch the 7 plus 12 into a group and then add x on the outside. And then I can simplify inside the parentheses, and this will be 19 plus x. So then that's my simplified answer. And all three of these expressions are equivalent. They all have the same value. So as long as I put x into this for the same value of x in for all of those expressions, they're going to be equivalent. Okay? I can do the same thing with decimals too. I could do 6.1 plus b plus 4.5. All right. Don't freak out just because it's decimals. It's the same thing, all right? Now, the commutative property also tells me that I can switch these terms and still get the same answer. So I'm going to not only switch the places of the b and the 4.5, but then the 4.5 ends up inside the parentheses, which is fine. Or I can just drop the parentheses. And then I'm going to add those two together because both of those are constants, and I can add those constants together. So if you can't do this mentally, then remember when you add decimals, you have to line up the decimals for adding. Bring the decimal straight down. Okay, so then my sum is 10.6 plus b. Okay, and that's as far as I can simplify it because I don't know what the value of b is. But all three of these expressions are equivalent to each other. They all represent the same value, even though they have a variable in it. Okay. One more example. If I have 5 times 11y. So there's multiplication. Okay. I can switch the groupings. I have 5, I have 11, and I have y. I have 3 different parts there. Okay. I can group together the 5 and 11 instead of the 11 and the y, and multiply those two together before I multiply by the y, and then I get 55 times y. Or I could have written 55y because when the variable is right next to the number, it shows multiplication. Okay, so all three of these expressions are equivalent to each other again because they show the same product. They represent the same value. Okay. All right, so those are the commutative and the associative property. You're going to get some more practice identifying the properties and simplifying using the properties. But we're also going to look at 2 more properties that you probably are familiar with, and maybe you just don't know that they're called what they are called. But we're going to look at the zero property of addition and the multiplication property of 0 and 1. So I'm going to turn my page here. Okay. Oopsies. Got the bell in there. All right, so the zero property of addition, and I know you can't see this yet, I'll have to move my notebook down. Oh, you can. Okay. Okay, maybe you can figure it out based on the way it's named. You're adding, okay, and what are you adding? You're adding 0. Now what happens when you add 0 to anything? You get the exact same thing. So that's what the zero property of addition is just that the sum of any number and 0 is that number. Okay? Like, duh, you guys have been doing that since 1st grade, right? So, like 7 plus 0 is 7, okay? It works with variables too. Y plus 0 is y. Okay? It's kind of common sense, right? But now we've got a name for it. And it's going to become a little bit, you're going to need to know it for when you get a little bit further into algebra. So that's why we bring it up now and we just introduce it now. Okay? Same thing with the multiplication property. So same thing with the multiplication property of 0 and 1. You guys have been doing this property and you already know about this property, but now it has a name. So the multiplication property of 0 and 1 just says that it's got 2 parts. The product of a number and 0 is 0. So anything times 0 is 0, right? And also the product of a number and 1 is that number. And you guys learned that when you learned your multiplication facts, right? So d times 0 equals 0. So any number, so I just put d. I could have said like 13 times 0 is 0. Anything times 0 is going to be 0. Okay. 13 times 1 is that number, 13. Or I can use it with a variable also. D times 1 is d. Okay. So we can use those along with the associative and commutative properties, again, to simplify expressions. Right. So you may have seen some things like this. Okay, when we're simplifying, let's say I have 9 times p times 0. Okay. Well, I can use my commutative property to multiply the 9 and the 0 together, and then multiply the p. Or you just know that anything times 0 is going to be 0, so it doesn't matter what this variable is, it's always going to have the product of 0. Okay. Same thing with 1. I can do 16 times s times 1. Okay. I can either group together the s and the 1, or I can switch using the associative or the commutative property. I can multiply the 16 times 1 together and then multiply it by s, which is just going to be 16 times s. Okay. So I can put those together. I know that's going to be my product. All right. So using all those properties today, you're going to be just simplifying expressions. You may be identifying those properties as well. Okay. Good luck.